All right, so continuing simplifying radicals. If we were to have something like a number out front times the square root of 72. We're not doing anything different than what we were doing before when it comes to simplifying the square root of 72. We're just going to continue to write the 7 out front. So we have 7 out front. That's not under a radical. We need to think of what would be a perfect square here times another number to get me 72. So what is a perfect square that goes into 72? 36 is going to be the largest one. 36 times 2 gets me 72. Are we okay so far? Okay, 7 you can't change. That's just going to be 7. The square root of 36, though, is what?
6.
So we write it as 6. We don't write it as the square root of 6 anymore because we took the square root and got 6. Are we okay with that part? The last part, we can't take the square root of 2, so we're just going to leave it. It's all multiplication. Okay? So now what can we do? 7 times 6, because both of those are not under the radical. What is 7 times 6? It's 42 square roots of 2. So what we can do is from the very beginning, we're going to type this in our calculator. 7 square roots of 72 is that number there, 59.396. And 42 square roots of 2 is also that same value, so I must have simplified it correctly. Is that okay? So I know that the last two problems on that first worksheet had a number in front of it. Tackle it like this. Okay? Now, there are also, there's going to be a whole other page on that third page, I believe is what it is, that looks similar to this, where you'll have a number out front and then radical. But then we get into multiplying radicals. Now, everything that we're doing today with these radicals will support us throughout this unit. Okay, so just keep that in mind. So, the first one we're given is 6 square roots of 4 times the square root of 9. Now you can do this a couple different ways. Since the 4 and the 9 are both underneath a radical, you can multiply those first and then simplify it, or you can simplify each one. Cool thing here is, what do you know about 4 and 9?
Perfect square.
They're both perfect squares. So we could write this as 6 times what's the square root of 4?
13.
Times what's the square root of 9? 6 times 2 times 3, you guys can do that. 6 times 2 is 12, so we have 12 times 3. 12 times 3 is 36, and that would be your answer. Okay. Now the other way I said you could go about it was I said that you could have taken 6 square roots of, what's 4 times 9? So we would have had 6 square roots of 36. Okay, well what's the square root of 36? So we have 6 times 6, which is 36, and you'll notice that we get the same answer regardless how we went about it. So it doesn't matter. You have some choices. Okay. The next one. If I have 7 square roots of 5 times the square root of 5, what is this one going to turn into?
25 times 7.
Not 25 times 7.
7 square roots of 25.
7 square roots of 25. Yes, that 25 has to still be underneath the radical. Okay. 5 times 5 is 25. You can multiply those because they're both under the radical. All right. What is the square root of 25? So we have 7 times 5. What's 7 times 5?
35.
And that would be your final answer. Okay. Notice that we had the square root of 5. Technically what we did here was we took the square root of 5 and we squared it. And that's how you end up with 5. Because if you square a square root, they undo each other. You're left with the number. Does that make sense? So when we took the square root of 5 and multiplied it by itself, we were squaring it, which is how we came up with 5 in the next step. You can always show your work and show this step and then you get that step. But that's why. Alright, number 3, we have 7 square roots of 2 times the square root of 3. What do you get this time?
7 square roots of 6.
Yes. 7 square roots of 2 times 3 is 6 for underneath the radical. Is there a perfect square that goes into 6? No. So that's our final answer. We have to leave it. Is that okay? What do you want to do this time? What is it? Yep, you want to multiply 8 and 4. So 6 times the square root of, what is 8 times 4? 32. We're on our way there. Should we leave it like this? Not this time. Why can we not leave that as our answer this time? It can be simplified. What is a perfect square that goes into 32? 4 goes into it, but there's something bigger. 16. So this becomes 6 times the square root of 16 times what gets you 32? Times 2. And the reason we chose 16 was because that was that perfect square. So what is the square root of 16? So we have 6 times 4 times the square root of 2. What do we have now? 24, because now we can multiply the 2 that are on the outside. So 24 square roots of 2. Okay. The next one. And some people like to, at the beginning, they see the square root of 4. And what's the square root of 4? 2. So then you'd have 6 times 2. So here, I'll write it out the other way, too. Some people like to say that that's 2. That stays the square root of 8, and this stays 6. And then the 6 and the 2 are both on the outside, so we would have 12 square roots of 8. But then you would have to, again, simplify 8 anyways. Which, what's a perfect square that goes into 8? 4. So we have 12 square roots of 4 times what? 2, which then turns into 12 times 2 times the square root of 2, which is 24 square roots of 2, which is exactly what we got over here. Okay, so it doesn't matter the way you go about it, you just have to get to this point in the end. Are we okay with that? We have questions there. All right, then 2 more for multiplying, then we'll move on to dividing. The square root of 6 times 3. What would I do? Can I multiply the 6 times 3? No. Why can I not multiply the 6 and the 3? One's under the radical, one's not under the radical. They can't mix. One's inside the house, one's outside the house. Doesn't work. So, what can I do here? Any perfect squares that go into 6? No. Is there anything you can do? There's only one thing you can do. put the 3 in the front. We never multiply a radical times a number. You always do a number times the radical. So we just like to put the 3 in front of the 6. So you just change the order of the multiplication. That's the only thing you can do there. Because the number you always want in front of the radical. Is that okay? All right. If I had 44 times the square root of 7, what's my answer here? Any perfect squares that go into 7? No. Can I multiply 44 and 7 together? No, because one's under the radical, one's not. So how am I going to write my answer? 44 square roots of 7. You just don't have to put that multiplication sign in there. Just put it up next to it. That's the way we simplify it. We just write it as one number. When there's nothing in between there, we assume multiplication anyways. Okay. Give me like a 1 to 5. I feel like pretty good about this whole multiplying radicals thing. Down to a 1. Whoa, I don't know anything that's going on right now. Okay. So, let's try dividing radicals then. Okay. The first one, I have the square root of 18 divided by 2. And when I do this, as a math teacher, as a mathematician, we rarely ever use a division sign like this. When was the last time you guys saw a division sign like this? In Algebra 1? But you probably didn't use it very often in Algebra 1. Nope. What do you use instead of division signs? A slash, which means just what? That over, it means it's a fraction, right? Fractions are just division. So what I'm going to do is I'm going to change this problem to say that it's the square root of 18 over 2. Because my answer has to be written as a fraction anyways, so I'm going to start with writing it like this. Are we okay with that? The division sign just means it's a fraction sign. Alright, then the next step is we have a radical here. We know how to simplify it. So the square root of 18, how is that going to break down? Square root of 9 times the square root of 2. We have to use a perfect square. So someone said 6 and 3. Neither 6 or 3 are on our perfect squares list. We have 1, 4, 9, 16, 25. So we don't want to just assume any two factor pairs. We want to pick a factor pair that has a perfect square in it. So 9 and 2 work because 9 is a perfect square. This is still written over 2. Haven't changed anything yet. What can I do now, though? The square root of 9 is what? So I can write this as 3 square roots of 2 over 2. That's it. Now I can double check this because in the beginning I had the square root of 18 divided by 2. And I got that value right there. And in the end I had 3 square roots of 2 divided by 2, which is still that value. And so I'm pretty sure that that is correct. Is that okay? All right, let's try another one. Square root of 18 divided by the square root of 2. Do I like a division sign? No, let's just put it as a fraction. What do you think we could do now? Ooh, there's something even easier than just simplifying that 18. Because both the 18 and the 2 are underneath radicals, what is 18 divided by 2? It's the square root of 9. Since they're both under radicals, you can take that operation 18 divided by 2 and get the square root of 9. What's the square root of 9?
3.
Now, if you went about it the roundabout way, so if we said, yes, this is the square root of 9 times the square root of 2 over the square root of 2, we would have said the square root of 9 is 3. We would add 3 square roots of 2 over the square root of 2. What's something over itself?
1.
We would have still got 3. So you can do it either way. It does not matter. Does that make sense? I'll get this back to you, so I know where. And then just go ahead and leave whenever you need to, okay? All right, so the next one, number 3. 3 square roots of 3 divided by the square root of 3. What's the first thing I'm going to do when I see this division problem? Write it as a fraction. So 3 square roots of 3 on top divided by the square root of 3 on the bottom. What happens? The square roots of 3 cancel because there's 1 on top and 1 on the bottom. Anything over itself has a value of 1. So this is 3 times 1 technically. What's 3 times 1? It's just 3 is my final answer. All right, now I'm going to really trick you. You don't think so? 2 divided by the square root of 3.
Is that your answer?
Oh, I would never have my answer have a division sign in it, so heck no.
Once you put it over.
Okay, so we want to write it as a fraction. 2 over the square root of 3.
Is that your
Absolutely not. There is a rule, and you are not allowed to have a radical in the denominator. What's that?
Is this number imaginary?
There is an imaginary number. It's also not allowed in the denominator. That you'll learn in Algebra 2, though. Okay, so you'll notice in all of our final answers, we have not yet had a radical in the denominator. Not here, not here, or here. Did that 2 ways. Not here. Now we have a radical in the denominator. I say it's like a house in the basement. Thank you. No, keep change. No, if you keep change flip, it would turn into this. 2 times 1 over the square root of 3. Keep change flip. When you multiply a fraction by a fraction, we'd have 2 over the square root of 3. We would have the exact same thing. Keep change flip is turning a division problem into a multiplication problem, but we already wrote it as the answer anyways. But the problem is that we can't have a radical in the denominator. Okay. However, if we multiply the denominator by itself, so if I take and I multiply the bottom by the square root of 3, I can do that as long as I do the same thing to the top, because what did I just multiply by? No, what did I multiply by? What's the value of this fraction? 1. It's called the undercover 1. Okay? It doesn't look like 1, but it does have a value of 1. Do you see that? The square root of 3 over the square root of 3 has a value of 1.
So that cancels out, and then it's just 2.
Well, let's look. So on the top now, what do I have? I have 2 square roots of 3 on the top. What do I have on the bottom? What would the square root of 3 times the square root of 3 be? It's the square root of what's 3 times 3? 9. Right? The square root of 3 times the square root of 3 is the square root of 9. But what's awesome is because we multiplied 3 times 3, that's now a perfect square. What is the square root of 9? So we have 2 square roots of 3 on top, and we have a 3 on the bottom. 2 square roots of 3 over 3. This is your final answer. It is okay. I promise it'll be okay. We're going to try another one of those. Maybe 2 more. Okay, so for this next one, we have 6 square roots of 5 over the square root of 6. So I'll just write it as the fraction to begin with. Okay. Now, can we do 5 divided by 6 since both are under radicals?
Yeah.
You could, but 5 over 6 doesn't help us because 5 is not divisible by 6, right? But if they were divisible, we could go that route, but these ones aren't. So what can I do? Multiply by the undercover 1. What is the undercover 1 that we're going to use? The square root of 6 over the square root of 6. Because that means I'm squaring the bottom. Okay, it means I'm going to multiply the bottom by itself. On the top, what do I get if I multiply 6 square roots of 5 times the square root of 6? 6 square roots of 30. Over, on the bottom, what do I get? The square root of 36. On the top, I have 6. Are there any perfect squares that go into 30? 1, 4, 9, 16, 25. Any of those go into 30? Nope. So we're going to leave it 6 times the square root of 30 over, what's the square root of 36? Okay? Anything else? Yes, 6 over 6 I can now do because now that they're both not under radicals, I can take care of those. 6 over 6 turns into 1. So what's my final answer here? Square root of 30. Okay. It's insane?
And there's so much work for such a little value. It happens.
It happens. Okay. All right, we'll do one more. What's the first thing I'm going to do? Do I like a division sign?
Nope.
Heck no, not us mathematicians. We don't. So I'm going to write this as the square root of 30 divided by the square root of 2. What should I do? Yes. Since they're both under radicals, you can divide these ones. What is 30 divided by 2? Square root of 15. Are there any perfect squares that go into 15? 1. Yeah, but that doesn't help. 4. Nope. 9. Nope. 16 is too big. That's your final answer. So just because you see a square root in the denominator does not necessarily mean you have to rationalize the denominator or multiply by that undercover 1. Okay? If you tried to, this is what would have happened, which it's not wrong, but some people go about it this way. So they had the square root of 30 over the square root of 2, and they said, oh, I have to multiply by my undercover 1. What would the undercover 1 here be? The square root of what over the square root of what? Square root of 2 over the square root of 2. Okay, what would I end up with on the top if I multiply the square root of 30 times the square root of 2? Square root of 60. what would I have ended up with on the bottom? Square root of 4. What's the square root of 4? What's a perfect square that goes into 60? 25 doesn't know. 25, 50. What is it? 4 and 15. What's the square root of 4? Now what could you do? The 2's would cancel, and what would I be left with?
But isn't that a different number than 3 over 4 though?
No, we got the square root of 15 before.
Oh, you did?
Yeah, way over here. We got the square root of 15. Because all we did was 30 divided by 2 and got 15. And everything was under radicals. But this process over here, look how long it took us. How many steps it took. And we got the same answer. So as long as you're following your rules, you really can't go wrong. It just is a matter of how many steps are you going to solve it in. Kind of cool? So, the rest of that packet there, those 2 pages, is the rest of your assignment. So, we have the rest of the time to work on that.